How to understand electric and magnetic fields for GED Science. Imagine invisible forces all around us, shaping how objects move and interact. These forces are called electric and magnetic fields, and they are the foundation of many technologies we use every day. To understand them, start with the basics of electricity and magnetism and see how they are connected through what is called electromagnetism. Electricity involves the movement of tiny particles called electrons. When electrons flow through a wire, we call this an electric current. Even when electrons are not moving, they still create an electric field around them. This field can push or pull other charges nearby without touching them. Think of it like an invisible force that acts at a distance. Magnetism comes from moving electric charges. When electric current flows through a wire, it creates a magnetic field around the wire. This magnetic field can attract or repel other magnets or magnetic objects. Magnets have two poles, north and south. Opposite poles attract each other, while like poles push away. This is why a magnet sticks to your refrigerator or why compasses point north. Electric and magnetic fields are invisible forces created by electric charges and their movement. An electric field exists around any charged particle, and a magnetic field appears when charges move, such as in an electric current. These fields are not separate but are linked through a concept called electromagnetism. Electromagnetism is the study of how electricity and magnetism work together. For example, if you run an electric current through a wire wrapped around an iron core, it becomes an electromagnet. This magnet can be turned on or off with electricity. This principle is used in many devices like electric motors and generators, which turn electrical energy into motion or vice versa. Understanding how electric currents create magnetic fields helps explain how many everyday gadgets work. For instance, in an electric motor, a current flows through a coil, producing a magnetic field. This magnetic field interacts with a permanent magnet, causing the motor to spin. This shows how electric and magnetic fields can produce mechanical energy. Key terms to remember include electric current, which is the flow of electrons. Electric field, the force field around a charged particle. Magnetic field, the force field created by moving charges or magnets. Electromagnet, a magnet made by electric current flowing through a coil. And poles, which are the ends of a magnet labeled north and south. There are some basic rules to keep in mind. Opposite electric charges attract, and like charges repel. The same goes for magnetic poles. Opposite poles attract, and like poles push away. Moving electric charges always create magnetic fields. Also, changing magnetic fields can induce electric currents in conductors, which is how transformers and many electrical devices work. Getting a good grasp of these ideas helps you see how electric and magnetic fields are part of many technologies around us. From motors to generators, understanding their relationship is key to understanding physical science concepts. Focus on how electric currents produce magnetic fields and how changing magnetic fields can generate electricity. This connection is at the heart of electromagnetism and essential for your GED Science test.